right, ladies and gentlemen, this is topic 9, lesson 2, day 2. Now, part of what I talked about yesterday when we found the factors of those quadratic equations that represent the zeros, what that looks like on the graph is the x-intercepts. So today we are going to do a little bit of graphing just because I want you again to make that connection between factoring and using those as x-intercepts. So again, the EQ is the same. How does factoring help you solve quadratic equations? Today your homework is a 9-2 additional practice worksheet. I did provide that as a Google Doc so you can make edits on it that way instead of printing or doing it on a separate sheet of paper, which you can still use those options as well. So we're going to use factoring to graph this function, f of x equals x squared minus 2x minus 8. So first of all, what we want to do is we would like to factor that. When we factor that, remember those two solutions are going to be the x-intercepts. So we're looking at what multiplies to get negative 8 and what adds to get negative 2. I'm going to say negative 4 times 2 gives us that negative 2. So I'm going to factor this function, x squared minus 2x minus 8 equals 0. Remember, we have to start with it set equal to 0, to x minus 4 times x plus 2. Now, zero product property says that I'm going to then set both of those equal to 0. X minus 4 equals 0. X plus 2 equals 0. I add 4 to both sides, and I subtract 2 from both sides. So x equals 4, and x equals negative 2. Now, though there are two solutions there, and remember these are our x-intercepts. So when we graph this function, I'm going to find x equals 4 on the x-axis and x equals negative 2 on the x-axis. Okay? Now, that's not it. We still are trying to graph this entire parabola. So we also need to find the vertex. One thing that's helpful to remember from topic 8 is that this negative 8, remember, is the y-intercept. So we can also graph that point there. That might help us with once we get the vertex and the axis of symmetry to get another point because we can reflect it over that axis of symmetry. So if we find the vertex, remember the x of the vertex is negative b over 2a. So I'm going to use negative 2 over 2 times 1, which is 2 over 2, which is 1. So x equals 1, then I'm going to plug that back in to get my y. So 1 squared minus 2 times 1 minus 8 equals not 0. 1 minus 2 is negative 1 minus 8 is negative 9. So my vertex is the ordered pair 1, negative 9. So I'm going to graph that here. Okay, and I have this axis of symmetry here. We should be able to check that these points are an equal distance from the axis of symmetry. They are both 3 away. And then I can make this point here because that's also reflected over the axis of symmetry, and then I can graph it. There is my parabola. Now, if I wanted to write this function in factored form, I would write it as f of x equals x minus 4 times x plus 2. Okay? So now, example 2 is giving us the graph and telling us to write the function in factored form. So we're going to write it like this, but we are given the graph this time. So there's some information that we need to know. Okay, we know these x-intercepts here are important. Okay, I'm going to write those down. And we know this vertex here is going to be important, and we're going to use that later, but I'm going to write that here. Okay, so if we have x-intercepts, what we know then is that x equals -5 and x equals 1. But what we want to do is we want to get those numbers with the x's and have it be equal to 0, just like in the zero product property up here. So I'm going to add 5 to both sides. And I'm going to minus 1 on both sides. Okay, so if I have x plus 5 equals 0 and x minus 1 equals 0, I can rewrite that function as 0 equals x plus 5 times x minus 1. Now, the difficult part about this is if we have a function f of x, there will be an a value here. Now this is where the vertex is going to come in handy. I can plug in the x value for the vertex for both of my x's and the y value for this f of x and solve this function, or this now what would be an equation for a, to determine what my a value is. So I'm going to plug in -9 equals a times -2 plus 5 and -2 minus 1. Okay, I can simplify. -2 plus 5 is 3. -2 minus 1 is -3. Still times a equals -9. -9 equals a times -9, so I can divide by -9 on both sides and get a equals 1. So when I rewrite my factored function, I get f of x equals 1 times x plus 5 x minus 1. Now that 1's important, especially if it's something different than 1, because we have to have that there. That's going to tell us the skinniness or the wideness of our parabola. In this case, we wouldn't have to write it there because multiplying by 1 doesn't change our function. Now on the left hand side, I want you to complete this try it. I'm going to do it and then I'm going to post a picture of it on Google Classroom so you can check your answer against mine.